A warm welcome to another lecture on communication engineering. I am Ramji, working as an assistant professor in the Department of Electronics and Communication Engineering at GCE Thanjavur. So today we'll be discussing about multiplexing, frequency division multiplexing, time division multiplexing, and channel encoder. What is multiplexing? When many signals are transmitted simultaneously in one channel and all the signals lie in the same frequency band, then they will interfere each other. For example, if multiple speakers are talking on same telephone line, then their voice will mix up. To avoid this situation, each source is allotted the fixed frequency band in the channel, or each source is allotted the fixed time slot in the channel. Multiplexing is a process of combining multiple signals by frequency division or time division for transmission over a single channel. In the case of frequency division multiplexing, FDM assigns a different carrier frequency to each data stream and then combines many modulated carrier frequency for transmission. The carrier frequencies are separated by a sufficient bandwidth to accommodate the modulated signal. This range of bandwidth are the channels through which the different signals travels. For example, television transmitter uses frequency division multiplexing to broadcast several channels at once. The bandpass filter is used for separating channels and allows to pass a specific range of frequencies. In frequency division multiplexing, channels are separated by unused strips of guard bands to prevent overlapping. But in the case of frequency division multiplexing, guard bands increase the bandwidth of FDM. Next, time division multiplexing. In time division multiplexing, the time frame is divided into slots. This technique is used to transmit all the signals over a single communication channel by allotting one slot for each message. Time division multiplexing can be classified into synchronous time division multiplexing and asynchronous time division multiplexing. In synchronous time division multiplexing, the input is connected to a frame. If there are n number of connections, then the frame is divided into n time slots. One slot is allocated for each input line. In this technique, the sampling rate is common for all the signals and hence the same clock input is given. The multiplexer allocates the same slot to each device at all times. But in the case of asynchronous DDM, the sampling rate is different for each of the signals and a common clock is not required. If the allotted devices for the time slot transmits nothing and sits idle, then the slot can be allocated to another device, unlike synchronous. Next, what is channel encoder? Channel encoder is comprised of voice encoder and decoder. In voice coder, the frequency spectrum of the speech signal from 200 Hz to 3200 Hz is divided into 15 frequency ranges by using 15 bandpass filters, each having bandwidth range of 200 Hz. The output of bandpass filter acts as the input for the rectifier unit. Hence, a signal is rectified and filtered so as to produce a DC voltage. This generated DC voltage is proportional to the amplitude of AC signal present at the output of the filter. The input of the frequency discriminator is a speech signal. Frequency discriminator unit is followed by a low pass filter of 20 Hz. This low pass filter generates a DC voltage proportional to the voltage voice frequency. The frequency represents nothing else than the pitch of the voice. This DC voltage also indicates whether the speech signal is voiced or unvoiced. Now the output of all the low pass filter is DC voltage, which is sampled, multiplexed and analog to digital converter. So we have the digital equivalent of speech signal at the output of the encoder. This encoded voice signal consists of frequency component from 200 Hz to 3200 Hz, information regarding the pitch of the speech and whether it is voiced or unvoiced. In voice decoder, the digital voice signal generated by the voice encoder is firstly decoder. The voice decoder using a speech synthesizer produces the voice signal at its output. It generally generates an approximate voice signal. The demultiplexer and digital to analog converter section convert the received encoded signal back to its analog form. Here the balanced modulated filter combination used in correspondent to rectifier filter combination at the encoder. The carrier to this balanced modulator is either the output of noise generator or pulse generator, but this depends on the position of the switch. However, the switch position is decided by the decoder. It is so because when voice signal is received, the switch connects the pulse generator output to the input of all the balanced monitor. Similarly, when an unvoiced signal is received, the switch connects noise generator output to the input of all the BM. But the position of the switch totally depends on the decision of the decoder. Only certain balanced modulator will provide the output the received signal is voiced. This totally depends on the frequency component of the received signal. But we can get the output from all the balanced modulator if the received signal is unvoiced. The adder will thus add up all the analog signal and produce voice or speech output. The next lecture will be discussing about the different digital modulation techniques. Thank you.